Hello everyone, my name is Roee Shraga and I'm an assistant professor at the Computer Science Department and Data Science program here at WPI. And today I'm going to tell you how I make better data for better science. Data is everywhere, and some of the main questions that we can ask about the data is where do we store it, how do we manage that, and maybe more importantly, what we can do with all this data. This brings me to data science, and specifically to the 80-20 rule of data science. This rule states that 80% of time data scientists spend is actually spent on finding, cleaning, and organizing the data, while only 20% of the time is actually spent on analyzing the data. Wrapping this all together brings me to my main research interest, which is data management research. In other words, we try to find efficient ways to find, clean, and organize data. There are additional alternative takes to the 80-20% rule. For example, Big Data Borat, which is a common Twitter account, talks about this rule as 80% of time spent on preparing the data and 20% of time spent on complaining how I needed to prepare the data. And for those of you who worked with data before and will work with data in the future, can definitely relate to this alternative rule. My research has four main pillars, namely data versioning, data discovery, data integration, and data quality. And I'm going to spend the next few minutes to tell you a bit more about some of the research projects that we have going on in my lab. For this context, assume that we have a group of scientists trying to look at data to predict whether a specific patient has Crohn's disease or not. My first pillar of research, which we refer to as data discovery, tries to discover or find new pieces of data that can be useful for this group of data scientists, or scientists in general. Specifically here in that example, we use a keyword search, specifically Crohn's patient data, to try to search this repository of tables and come up with this piece of information that can be useful for these scientists. One question that you may ask is how to integrate these pieces of information, which is in another pillar of research of mine called data integration. The method that we use in this research is mainly multimodal deep learning, contrastive learning, and knowledge graphs, and obviously a lot more. The second pillar of my research looks at how to integrate these pieces of information together. In other words, we try to find efficient and automated ways to combine these pieces of information, for example, the scientist data set and additional data set that they discovered, together to come up with one efficient combined view of the data set. The method that we use for this research range from graph neural networks and large language models such as ChatGPT to cognitive science. Specifically, we look at how humans perform these tasks, or how humans perform these tasks, try to benefit from ideas and insights to our machine learning automated solutions. Another interesting research that we have is looking how people work with the data. Specifically here, we look at collaborative data science. Assume that we have the same data set as before that was used by the scientists, and they created 3 new columns. While another set of scientists look at this data set, they don't know what happened to the data. Specifically, we see 3 more columns. One of them may be beneficial. For example, one column here is the BMI of the patient. But since people do not document the data changes that they do, we cannot know for a fact what happened to the data set. And in what follows, my research tried to explain these changes in an efficient and automated way. You may ask how relevant it is. So specifically, if we follow the IDC, which is the International Data Cooperation, we see that 90% of the new generated data nowadays is actually replicated. Or in other words, 90% of the data that is being generated in heavy masses is actually versions of data that already exist. Using this type of research, we can benefit from understanding the changes that happen to the data and try to understand better the new data that is being generated on a day-to-day basis. The method that we use in this kind of research mainly rely on explainable AI, so generating AI and machine learning solutions that humans can understand, and also builds on top of symbolic AI. I'm Roee Shraga. If you have any other question, this is my email, this is my website, and I'm happy to take any questions. Thank you for listening.